Today I'm going to introduce myself in Te Reo, the native language of my home country, Aotearoa, New Zealand. Kia ora koutou katoa, ko Matt Simpson takawingawa, ko takamahi ki AWS, ko te kaihanga, which translates to, hello and welcome to you all. My name is Matt Simpson, I work for AWS, and my role is a solutions architect. In this session, we are going to build real-time application orchestration at scale, and I will also be joined by Teddy Hiti from Beem. We are going to be covering the following topics: how we can map our business workflows to AWS Step Functions, which allows us to focus on the higher valued business logic. We will cover the differences between standard and express workflows, and then dive deep on synchronous express workflows for use in real-time applications. I will then run through a demo to show this in action. We will then hear from Teddy Hiti, DevOps lead at Beem, on how they built their new digital payments platform, EQR, using Step Functions' synchronous express workflows. Typical business workflows are multi-step processes that have multiple decision paths and need to handle failure gracefully to ensure data consistency. There may also be requirements for orchestrating events to run in sequence or in parallel at different steps of the workflow. Building a modern application, we can approach these challenges in a number of ways. We can coordinate the workflow steps using a database, a set of queues, or by chaining functions together in a process. Whilst these approaches are valid, if we choose to model these business workflows with AWS Step Functions, we are able to offload some of the undifferentiated heavy lifting of managing the state of the workflow execution. Using Step Functions allows you, the developer, to focus on the specifics of the business workflow and less on the supporting infrastructure to make it happen. Step Functions was launched over 5 years ago at re:Invent 2016. When it was first introduced, it supported asynchronous workflows, later to become known as standard workflows. Asynchronous express workflows were launched at re:Invent 2019, and as you can see in the table, have a shorter duration, higher throughput, and were designed to be more cost-effective at scale. If we look at a typical asynchronous pattern, we have a client application submitting data to an AWS API gateway. This will invoke an asynchronous express workflow using the start execution command. The workflow will start and return the unique Amazon resource name, or ARN, for the execution, but does not wait for the workflow to complete and return any other output. It is then the responsibility of the client to poll using the execution ARN to check if the workflow has completed. In this case, it is still running, so returns that fact to the client. The client would then repeat this step, implementing a retry strategy until the workflow returns successfully, and along with it, the output of the workflow. Synchronous express workflows were introduced at re:Invent 2020. With this launch, we enable developers to quickly receive the workflow response without needing to poll additional services or build a custom solution. This is useful for high-volume microservice orchestration and fast compute tasks that communicate via HTTPS. Changing our previous scenario to use synchronous express workflows allows us to invoke the workflow using the start sync execution. This instructs Step Functions to start, run, and return the result without the need to poll, and is ideal for real-time user interactions. So as you can see, there are a number of trade-offs that need to be considered when choosing between the different workflow and execution types. For greater scale and execution rates, you might choose express workflows. But if you need an asynchronous task to run for more than 5 minutes, then standard workflows would be required. It is also important to highlight the execution semantics, or execution guarantees as they are often referred to. Standard workflows support exactly once processing. You can use the execution name to guarantee this. Express workflows, due to their shorter duration and scalability, support at least once and at most once processing, depending on the execution type. Now, links to the specific details around this will be shared at the end, but it is important to note that when using express workflows, the execution step needs to be idempotent, which is to say that the workflow execution could fail and need to be retried, so any data persistence logic would need to support this. Let's look at a sample application that implements both synchronous and asynchronous express workflows. Here, I have built an expense claim application which takes an employee claim details and receipt image, validates the details, and uploads the receipt image to Amazon S3 for further processing. The synchronous request is used to assist with our claim validation and provide a real-time response to our users if there is a problem. This is a great use case for complex validation logic that doesn't need to be built into the client and can be reused across the back-end services. Once the image is uploaded to S3, we trigger an asynchronous express workflow to process the image using Amazon Textract. Amazon Textract is a service used to detect text in images and is also able to extract data from receipt images, such as the vendor and total amount. We then update our database record and notify the client application using a webhook to complete that real-time feedback to the end user. Let's take a closer look at our synchronous workflow and validation pattern it is running. Once the user submits the claim, it is validated using a number of external microservices. Here, we are using a parallel step in the workflow, as both the claim and identity need to pass validation. Doing so can speed up the overall execution and improve the experience for the end customer. Should the validation fail, for any reason, it is returned to the customer immediately so they can find out what went wrong and amend their claim. If the validation succeeds, a record is saved in DynamoDB and an S3 pre-signed URL is provided so the front-end application can upload the receipt image. So here is our front-end application hosted by AWS Amplify. Now I've been raging a customer event and need to make a claim for some catering. So I create a new claim and enter the required info. I select my receipt image and upload. This calls the backend API and triggers the synchronous workflow. The validation passes and we were redirected back to the summary page. Once the receipt image upload is completed, it triggers the asynchronous workflow, which, as you can see, has completed and updated the details via a webhook. If we look at the details, you can see that the vendor and total amount has been detected from the image, just to show this is a working piece of software. Now I also have a claim to process for a meeting with one of my team. So I create a new claim and update the attendees. I select the receipt image and upload. But as you can see, one of the validation steps has failed. But this is a synchronous workflow. We have stopped the processing and returned the failure back to the end user in real time. Now let's look at some of the tools I used. Initially, I developed the sample application using Step Functions Workflow Studio. This is a visual designer for Step Functions that lets you use a canvas to create and edit workflows, control how input and output is filtered or transformed for each state, and configure error handling. Now, this is a great way to get started and iterate quickly on an idea. But once that idea matures, we are also able to export our workflow definition and use this in our source code and infrastructure as code pipelines, or for local development and testing. Here, we have taken an export from the console and are able to use it with a number of popular infrastructure as code solutions. AWS CloudFormation, the AWS Serverless Application Model, the AWS Cloud Development Kit, Terraform, and more. Step Functions also supports local development and testing using a local Docker image or Java package. In February 2022, we announced the support for mocking service integrations with AWS Step Functions Local. This allows developers to define sample outputs from AWS service integrations. You can combine them into test case scenarios, which are shown here, to validate the workflow. This can help if you want to test the flow of state machine executions in isolation without any external dependencies. And finally, observability. Here I have enabled AWS X-Ray tracing across API Gateway, Step Functions, and Lambda. This is supported for synchronous express workflows and provides insight into potential areas for optimization or further investigation. As you can see here, we are able to complete our validation, persist data, and provide a pre-signed URL all in a few hundred milliseconds, which supports our real-time use case and fast feedback for our users. I'm now going to pass to Teddy to talk more about how Beem use step functions.
Thank you, Matt. My name is Teddy Hiti, and I'm a DevOps lead at Beem. I would like to start by introducing Beem and the new QR payment platform. Beem is Australia's favorite financial application. It's the one app in the financial space that people love. 1.7 million people use Beem to instantly pay friends and family, split payment, request money, and much more. We have maintained a 4.7 star rating across both Apple and Android Store. And we were able to do it because we care about our user. We care about their privacy and security. We care to support them. And most importantly, we always listen to their feedback. The magic of Beem is its simplicity. I would say, hey, pay Matt $5 for coffee. And I can even send Matt an emoji or a personal note. I can also share the experience with my network and even refer a friend and get rewarded. So it's not just about paying money. We have extended it to connecting people together. Beem is completely free for users and operates between all of the banks. It was originally founded by 3 of the big 4 banks, which did all the plumbing to get the system working, and then it was bought by FPOS Australia. We are proudly Australian, owned and created. Our application is hosted on AWS in Australia, and the data is owned and controlled locally as well. With Beem, the card details are never shared with merchant, which negates the need for merchant compliance and provide the cardholder with additional security as their details are never shared outside of the wallet. QR payments are quite different from either magnetic card or NFC tap-and-go payment. When we engage with traditional card-based payment, the exchange of data between cardholder and merchant is almost non-existent and involves only an account number and expiry date. However, with QR payments, we allow for a rich exchange of data throughout the entire conversation between merchant system and cardholder wallet. Imagine we could instantly split payment across multiple cards. Imagine we could instantly receive a digital receipt and have it stored in the wallet. Imagine we could instantly access all of the offer from our favorite merchant just by registering the card once in the wallet. Imagine we could instantly update our card details without having to update it at every merchant in-store or online. Imagine we get rewarded for any transaction, whether we're buying a coffee, shopping at a mall, or booking a holiday, or even for purchasing online goods. Imagine we can do all of the above without having to share our card information with anyone outside of the wallet. Well, the good news is there's no need to imagine anymore. We have done it. And we did it on AWS. As this environment is deployed as national infrastructure by FPOS Australia, it's paramount that the solution encompasses security, performance, resilience, scalability, and more. These needs lead us to a completely serverless outcome and ultimately to Step Function as our orchestration component. A frequent question asked is, why use Step Functions? Resilience and scalability were paramount in our design, which led us to seriously consider a completely serverless build. In addition to mapping complex business logic into a simple JSON file, Express Step Function allows us to maintain data consistency across multiple services without tight coupling, ensure that workflow run in order and as expected, deal with errors and exceptions based on our business logic, improve code reuse, which help fast-track our path to both code maturity and solution delivery. Another major consideration was that we came to realize there were more unknowns than knowns in the current business roadmap, and the business flow would only get more complex. After filtering all of these challenges, the use of Lambda State Manager within Step Function orchestration was an easy one. We wanted to avoid using the daisy chain approach, where the client has to call multiple APIs synchronously, and using queues or SNS to decouple the business function. By using the Express workflows, we were able to minimize the amount of information that we send back to the API caller and avoid transferring a large volume of data in and out of our cloud environment. This has improved our security and execution time, as an entire workflow is triggered by a simple API call. Also, we were able to alter data and schema and even add further steps to our workflow without impacting existing processes or client. When building the QR orchestrator, each business problem was represented by a sequence diagram that covers the entire operating environment. Each of these interactions is mapped to an API call. The QR orchestrator, represented in the gray box on the right-hand side, is exposed through an API gateway. When a HTTPS request hits our endpoint, it triggers a sequence of action. If everything is successful, we do what's in green. In the case of an error, where the merchant is inactive or keys are expired, then it would return an error response, which is represented in the red piece. After designing the sequence diagram, we came in and said, let's work out exactly how to implement that. So then we created the workflow diagram. In this slide, we illustrate the create order workflow. We start with the verify merchant step, which once completed successfully, will then flow to the next state. An order is then created with a unique QR code and sent back to the client. The reason we broke it like that is because the verify merchant is a code that we use in every single API call across the entire platform. By creating it as a separate service, we get to reuse it in multiple workflows. By using Step Function, we were able to implement the above workflow by defining a state machine and a set of tasks. Each task makes decisions based on its input, perform actions, and pass output to the next state. Some of the workflows are very small, and someone could argue that it can be done in 2 lambdas. And there's no doubt about it. But what you cannot do is what we're about to do in EQR. So in EQR, we wanted to improve our security by adding HMAC authentication to all our API calls. Then, we would inject a verify HMAC step into all our workflows, which means we're going to write an additional Lambda that knows how to verify a HMAC. We will have to write it once, and then we plug it into all our step function. This will reduce the impact and the testing requirement for each of the workflows. We even did it as a parallel branch, so there will be no impact on performance and no risk of processing logic that went wrong. Moving into our high-level design pattern. Each API implementation follows the same pattern. An API gateway will accept an incoming request and trigger a transformation Lambda, which will kick off an express step function. Each step function have their own repository, and they can use various components of the AWS infrastructure, such as SQS, SNS, DynamoDB. We specifically use queues for rollback as part of the Saga pattern, and we use SNS for notification. Each one of the Lambda have access to all sorts of stuff like encryption, key management, X-Ray, and CloudWatch log groups. We use Kinesis Firehose to stream all our CloudWatch log to Datadog for visibility and monitoring. We also use PagerDuty for operation and incident management, and Datadog for dashboarding and monitoring. It's worth mentioning that we are also looking into CloudWatch dashboarding now that it has a very rich support for dashboard and alerts. We have also enabled X-Ray across all our infrastructure, which allow us to trace requests and monitor performance across the entire workflow. This helps us identify and troubleshoot the root cause of performance issue and errors. Now looking at our implementation diagram. We have a public API gateway, which will route the request to a transformation Lambda. It will run some validation and set some correlation ID. Then, it will trigger an express step function and wait for its response. When we built this solution, AWS had no support for integrating API gateway directly with step functions, which now they do. The express step function will trigger the verify merchant Lambda, followed by the create order. A major challenge we faced is that we wanted to guarantee that all our QR code are globally unique, and they fit within the constraint we have for codes. So we couldn't use GUID because we wanted to use a shorter code. In the case where a phone's camera is broken, we wanted the user to be able to manually enter the QR code. In our case, it's a 14 digits, so it's easy to key in the phone. We were able to resolve this by leveraging SNS and SQS. As you can see, the create order Lambda get the QR code of a FIFO queue, and then using SNS, it will generate an event in the background to create additional QR code and store them back in the queue. By using this approach, when the Lambda obtains a QR code of the queue, we guarantee that it's unique combination of 14 digits, and most importantly, it's a very fast operation. We're talking about 40 millisecond round-trip response. The future of payment is QR, but with Beem, the future starts now. Come join us. Thank you for watching. Back to you, Matt.
Thanks, Teddy. It's been amazing to see the success and scale Beem has achieved using AWS Step Functions. So wrapping up today, we have shown you the differences, benefits, and patterns for using AWS Step Functions Synchronous Express workflows. Beem showed us how they use step functions for Saga patterns in real-time user interactions and transactions that scale to hundreds of thousands a second. Offloading the state management so that development and operations teams can focus on solving business challenges and not managing the underlying infrastructure. We also saw how Beem were able to extend their existing workflows and reuse code across the solution for additional security validation. We looked at how we can improve the developer's inner loop with local testing and mocking, and the operations teams with detailed observability metrics. Kia ora, and thanks for watching. We really value your feedback to help us improve our sessions, so please share your out of 5 rating.